Okay. First of all, everybody needs to be on GeoGebra spreadsheet. So you go to GeoGebra spreadsheet. Okay. Go ahead and it should open that spreadsheet for you. You need to click on this button here, the plus button in the top right of the spreadsheet. And you also need to click on the 3 dots, and you need to add the Algebra tab.
Hold on, do that one more.
Click in the top right of your spreadsheet.
Okay.
Click on the 3 dots.
Oh, that's why. Oh.
I don't have it anymore because I already clicked on it.
That would be mine.
You aren't the right.
Mine is not a spreadsheet. Not a spreadsheet on the left.
You didn't go to the right.
Is the spreadsheet on the right?
Yes.
That's fine. As long as there's a spreadsheet and an algebra tab.
You just need to.
It should be the exact same thing you've always done when you got into Google Spreadsheet or into GeoGebra spreadsheets. Okay? After you do that, go to column A and type 1, 2, 3, 4, 5. Good?
Yes.
Go to the column, top of column B, type 5, 10, 25, 49, and 72. Just make sure you type those so we all have the same numbers. Okay? Just like we've always done, highlight it. In the bottom right of that box, right click. And then what? Create list of points. Magic. Now we have points. Okay? Everybody with me still? Okay. You said no. Why?
Just the highlight.
Oh, well, yeah, you came in late. Okay? And then, this is where things get different. Okay? To that point, that should all be normal. You've done that. Okay? You can get rid of this spreadsheet now because you don't need those points anymore. So you can just get it out of your way so you can see a little bit better. Click on where it says input. We used to type what?
Fit line.
Fit line for a line of best fit. Now we are typing fit poly for a polynomial.
God.
Now, as you look here, there are 2 options. There's fit poly, freehand functions, degree of polynomial. Don't do that one. Okay? The top one says list of points, comma, degree of polynomial. Okay? Before we do that, you need to understand what the degree of the polynomial is. What we are doing, the degree is 2.
Yes. Thank you.
Why was that so exciting?
There's some people that need to get their work done. So the degree of our polynomials is 2 because they are quadratic functions. X squared, that's the degree. That number on your highest exponent is your degree. So if I happen to have a graph with an exponent of x to the 7th, your degree would be 7. Does that make sense?
Yes.
So we're doing quadratics, which have exponents of 2's, right?
Yes.
Either x squares or y squares. Our degree is 2. So click on the fit poly with a list of points. It should have highlighted the list of points already. So you're going to do A, comma, B, comma, C, comma, D, comma, E. There's our points. Comma 2, because that's our degree.
Oh boy.
And it should have graphed a parabola for you. I literally just went over the degree.
Oh my God.
You weren't listening if you missed all that.
Oh no.
I have a few too many little things here.
How'd you get that equation? Look at Sean.
We are going to start going through the different ways to write quadratic equations. We did this in the last lesson, except in the last lesson we always either knew the focus or the directrix or the vertex and one of the other ones, or they told us what P was, or something like that, right? Okay? In these ones that we're going to do today, they don't give us any of that. You don't know where the focus is, you don't know anything about the directrix, you don't know the value of P, and it won't help you to find it. Okay? Because you actually won't have enough information to find it. So, the first way that we are going to look at is if you are given a point, which would be x comma y, and the vertex. You should know what vertex form of a quadratic looks like. If you don't, you have some work to do before our test. FYI, this is the last section.
Oh no.
So you got some work to do if you don't know what vertex form is. Okay? Because since they give us the vertex, that should be the dead giveaway that you use vertex form. Y equals a x minus h squared plus k. That's the equation that we are going to use to write this quadratic function. Okay? So, the example that I have in my textbook says, and I'll write the graph here in a second, says the graph shows the parabolic path of a performer who is shot out of a cannon, where y is the height in feet and x is the horizontal distance traveled in feet. Write an equation of the parabola. Okay, and then they give me this graph. That's the starting point, meaning what?
That's how high, like, the cannon are.
So the cannon starts 20 feet off the ground. Okay? There's the vertex. What's that mean?
That's the highest point.
That's the highest point, which is how high? 30 feet. How far away was he when he went 30 feet?
25.
25 feet away from the cannon. Okay? And then the last point they give us, we can't really tell exactly where it is, but it does show that, or it does tell us later in the sentence that there's a net that he lands in that is 60 feet. Make sure I say this right. Yeah, it's 60 feet away from where he started. So that means over here, this is 60 comma
X.
something. We don't know right now. Okay, we'll find that out later. Okay, first they say write an equation of the parabola. Okay, well, what I would do is I would just start with this equation because I know it's got a vertex. So I would start with y equals a x minus, but what is h?
Left and right.
Okay, so it's the x value of your vertex, which is 25 squared plus 30 because k is the y value of your vertex. Okay, so I have that much. Now, looking at that, what variable is usually filled in when we are given a quadratic in vertex form? A. We usually know what A is, correct? Does that helps us know whether it opens up or down, what the horizontal stretch or shrink is, or vertical stretch or shrink? Okay, so we have to figure out the value of A to be able to finish this equation. Yes, Peyton?
Why is it 25? Oh.
It's a vertex.
Okay.
25, 30.
Alright.
Just remember, H and K is the vertex. So that's my X and Y value of the vertex.
Wait, isn't A gonna be negative?
A is going to be negative, so you can tell that much just by the graph, right? Okay. Now we're not entirely done with this, so we'll have to finish this in a second. There's going to be an extra part that we have to add, but we need the rest of the equation first. So, do I know a y value and an x value?
Yeah.
Another one besides the vertex?
Mm-hmm.
Yeah, what is it?
0 and 20.
0, 20. Okay, they have to give you another point, or you have to be able to find another point for this to work. So my y value is
20.
20 equals a times
0.
0 minus 25 squared plus 30. Okay, so I have 20. What is 0 minus 25? Negative 25 squared.
625.
Positive 625 times a.
So you have to
625a. And then plus 30. So I subtract 30, I get negative 10 equals 625a. Divide by 625. And a equals what?
like a fraction or a decimal?
Preferably a fraction.
So like 2 over 125.
Negative 2 over 125. Okay. So there's our a. Why did we find our a?
That's what we're missing.
Because that's what we're missing in our equation, right? So what should we do with it then?
Plug it in.
Plug it in. I'm going to go back up here. I'm just going to erase and put negative 2 over 125. Okay, so now I have my equation. Now, it also says later in this sentence that this performer lands 60 feet away in a net, right?
Mm-hmm.
Meaning, well, first of all, the parabola started here, right? It didn't start back here, correct?
Yes.
So he didn't start at negative feet. That doesn't make any sense. But then it ended over here at 60 comma something. Okay? Does it go on after that?
No.
No. So we don't have a full parabola here. Can we all agree on that?
Yes.
Mm-hmm.
We have to restrict it then, because if I typed this into a calculator or onto GeoGebra, it would give me an entire parabola. We don't want an entire parabola, correct?
Yes.
So we have to restrict it. So my parabola starts at 0. Does it contain 0 or not? Yes, because there has to be a starting point. So I can have any x values from 0 all the way until 60. I have to restrict it because because if I didn't restrict it, this parabola would keep going here, right?
Mm-hmm.
Hey, well that doesn't make any sense because he didn't start negative, right?
Yeah.
And if I didn't restrict it on this end, he would keep going, which doesn't make any sense because even if he did go through the net, he would probably then fall straight down. And even if he didn't fall straight down, I don't think he's going through the ground. Right?
Yes.
Okay?
Never know.
So you have to restrict that because we don't need that whole parabola, we just want a portion of it. Okay? So this would be the answer to the question of what is the equation of the parabola. That's the equation, that whole thing.
Wait, will we be able to we have to put like all that into like the block?
They will give you, I think they give you extra boxes to do the bottom part. Yeah. Okay.
We have to find that other y value.
So then the next question is, what is the height of the net to the nearest foot? Well, I know that the net is over here at 60, so if I plug in 60, I should be able to get the y value, correct?
Mm-hmm.
Go ahead and do that quick.
Question. Why don't we find like
Once you plugged in 60, you should have got 10.4, which rounded to the nearest foot is 10.
You got negative 2.
Okay? So meaning that net, 60 feet away, is 10 feet off the ground.
Squared plus 30. You multiply something by 25. I don't know what I did.
Okay?
How do you multiply something by negative 2?
just put negative 2 over 125 in
whole thing in
parentheses
there.
and multiply it by it. I'll show you in a little while if you need me to. Or take negative 2 divided by 125 and change it to a decimal and then multiply it by that.
You can just type the whole thing into the calculator.
Yeah, if you know how to type it in the calculator, you can just
Watch this.
type the whole thing in. Okay? Alright. I want to go on and I want to do one like example 2 as well. And this will be our last example for today, and then we will do the example 3 tomorrow because that's a little bit longer. Alright, so example 2 helps us if we are given a point xy and the x-intercepts. Here's another one. If you don't know intercept form of a quadratic function, you need to know it. Test is Tuesday. Okay. This problem.
I have a question. So like the last one, it gave us that graph. Like we had x-intercepts. Like why didn't it mean? You know what I'm saying? Like from the graph, like we had 0 and oh, just kidding. But we had
Good. Okay. So this tells us the meteorologist creates a parabola to predict the temperature the day after tomorrow, where x is the number of hours after midnight and y is the temperature in degrees Celsius. Write a function that models the temperature over time. Okay, so here's my graph. So it's currently 6.3 degrees Celsius. I know that there's an x-intercept at 6, 0, which is 6 hours, and after 21 hours, it is 0 degrees Celsius. Okay. And if you had the same graph that I do, you would be able to tell that the scale is by 3 and that other point over there on the far right over here, well, I guess they told you, it was day after tomorrow, which is how many hours away?
24.
24. So it'd be 24 comma something. We don't know what it is, but if we had to, we could plug it in after we found our function, right?
Yep.
Okay. So, again, before I even do this, does this function work outside of 0 to 24 hours?
No.
No. So immediately you should understand there's going to be a restriction here. Okay? We could probably write the restriction right now because I know x is going to have to be between 0 and 24. Otherwise, this does not work. Does that part make sense?
Yeah.
Okay, I don't know. He says the parabola doesn't work after 24 hours. Okay, why? Well, I don't know. Maybe it comes back down. Okay, maybe the front comes through something. Okay, regardless, he only knows that it works for the 24 hours. So I have y equals a times x minus, what's one of my intercepts? 6. And my other one?
21.
21. Would it have been okay to switch those around?
Yeah.
Yeah, that wouldn't matter. Okay. So I have this, but I'm missing my a again. Correct? So same thing, different function, or different form. Same issue, different form. Do I know an x and a y that I can plug in?
Yes.
Yeah. Notice there's two x's, so you have to plug x in both places. So my y is 6.3. X is 0. X is 0. Put that away, please, or shut it down.
Wasn't me that time.
It wasn't me that.
Okay. So I have 6.3 equals, what's 0 minus 6?
-6.
So I have a, -6, and -21, right?
Yes.
Okay. What's -6 times -21? Positive 126. A. Divide 6.3 divided by 126, and I get a equal to 0.05, and we had a decimal already, so if you want to leave that as decimal, I'm okay with that. Okay, so now we found a. So now what should we do with it?
Plug it in.
Plug it in. Okay. It is positive, is that okay?
Yeah.
Yeah, it should be.
It's opening up.
Okay. And we went ahead and we already did our restrictions, so there's the equation that models our problem. Okay. And then the directions go on to tell us, they want to know what is the coldest temperature.
Oh, I know. 21 plus 6 divided by 2.
Okay, 21 plus 6 is
27.
27. Divided by 2 is 13.5. So I know that the x value of my vertex is 13.5. If you would please go ahead and find the y value. What'd you get? 10.
-2.8.
Good, -2.8. Okay, so the coldest temperature is -2.8 degrees Celsius, which would be 13.5 hours after we started, which would be like 1:30, right? Okay, now here's the next part, and I'm going to leave you with this thought, and we'll come back to it tomorrow at the beginning of class. The next thing they want us to find is the average rate of change from the start to the coldest temp, and then from, how do they say the next part? Oh, they say what is the average rate of change when the temperature is decreasing and when the temperature is increasing. Okay, so this is how we do that. You go to your starting point. And whether you have to make yourself a note or whatever, like I said, we'll talk about it again tomorrow. You go to your starting point. You go to your coldest temp. You need to find the slope of that line. That would be the average rate of change. Okay? Anybody remember slope formula? That's slope intercept formula. Slope formula.
Just gotta do that thing over 2 or over each other.
So you would have to do slope formula for that line. Okay? So the average rate of change increasing for the time it's increasing would be from here to here. Well, you need to know that other y value then, right?
So since it's like there to there, does it matter? No, never mind. Stupid question. Take one.
Good?
You have to know
Yeah.
both of them?
No, it was a bad
Well, yeah, because they wanted the average rate of change while it was decreasing temp and while it was increasing temp, and then they wanted you to compare them. Okay? So, like I said, we'll refresh you on that tomorrow. You should be able to finish through problem number 21 on your assignment. You're going to want to do all or most of that because tomorrow, example 3 is solving systems in 3 variables again. So you're going to want extra time to be able to handle that. Okay?